Hello students, I am your course instructor Professor Anisa Shikalgar. So in today's video we are going to see construction of the deterministic finite automata. So here I will write the heading construction of DFA that we will see in today's video. So here I have written one question. What is that question? Construct DFA for. See here students, for construction of DFA two types of questions they ask. Either they will give direct regular language, which is that particular part, that kind of example, or they explain the how the tuples will be, and from that tuple you can design the DFA. So that is a very simple part. Most of the time for construction of DFA the examples are on the language based, means the second example which I have written on the board. So here that particular example, in that tuples are given, means q0, q1, q2, directly they have given three states are there, 0 and 1 input alphabets are there, then delta q0 is initial state, q1 is acceptance state, and the transition functions are given. So here it is very easy to design the DFA, means q0, q1 and q2. q2 which is the acceptance, q1 which is the initial, q0. Then q0 on 1 it goes to q0. See here students, that is the transition function. Directly they have explained q0 on input 1 it goes to q0. Then q0, q1 on input 1 it goes to q1, on input 1 it goes to q0. q0 on input 0 it goes to q1. So q0 on input 0 it goes to q1. Next q1 on input 0. q1 on input 0 it goes to q2. q2 on input 0 it goes to q2, means one loop is there. q2 on input 1 it goes to q1. So q2 on input 1 it goes to q1. So for each and every state we have completed all the transitions. 0, 1 of q0, q1, 0, 1, q2, 0, 1. Means definitely we can call that particular diagram as a DFA, because it can completes all the rules of the construction for the DFA. So that is the deterministic finite automata. So see students, that kind of examples are very easy. So here it is for the start of the construction of DFA we can take this kind of example, but these kind of examples are not coming in your theory paper. So here it is easy to understand how to construct the DFA. Then we will move towards the next example in which the language is given. What is the language? A raised to n b and n is greater than or equal to 0. Construct the DFA for that particular language. So see here students, here again not any kind of information they have provided. Q, summation, delta, here all the informations they have provided. Okay, so these are some means difficult to understand these kind of examples. Okay, so here first it is necessary to write the which kind of string that particular language accepts. See here, n is greater than or equal to 0. When the value of n is 0, at that time it can accept only b. Then ab, then a square b, a cube b, likewise all the string it will accept. Now the students, here first see the minimum length string. What is minimum length string here? B. What is its length? 1. Okay, so that what rule I am going to tell you, that rule is 70% matched up while the construction of the DFA. The minimum length string is B, its length is 1, then 1 plus 1 means 2 states are required for constructing the DFA. So length is 1, 1 plus 1 is equal to 2. Number of states we point in that particular diagram. So that rule is, I told you, 70 to 80% that rule is applicable while constructing the DFA. So here I will consider Q1 and Q2. So it will be my initial state and it will be the acceptance state. So which is the minimum length string B. So from Q1, if B goes to Q2, it will be accepted. So that particular string will be accepted. Now which are the next strings? AB, A square B, A cube B. So it will increase about the A. So here we can design the loop of A at Q1. So see here students, now it can complete all the strings by that particular diagram. Only B accepted, B it is accepted, then A square B, that loop will be executed 2 times, then B, A square B, A cube B, 1, 2, 3 and B, that is also accepted. Now all the string it accept, but whether it is DFA, students, again remember the rule which we have seen while construction of DFA. What is that rule? A and B, from Q1 it goes to another state. Then what about Q2? From Q2, A it should go to another state or that particular state, and also for B. So from Q2, can I give A to the Q1? If we give like this A, then the meaning of the language will be changed, because A, B, again A, B, that string will be accepted. So the meaning of the language will be changed. Again, suppose I have given the B of Q2 to Q1, the language meaning is changed. Therefore, here it is not possible to give Q1, Q2, from Q2 and B we can't give to Q1. Again, here if I provided the loop, then also the language meaning will be changed. Therefore, in that particular case only, if I can't give the input alphabet to the states present in that particular diagram, then only we are considering the dead state. What is that? Dead state, and give the remaining transitions to the dead state if the transitions are not applicable to the states in that particular diagram only. Means first check from Q2 can I give to Q1, or from Q2 if I provide the loop to the Q2. If it is not possible, then only we are considering the dead state and give the remaining transition to dead state. Now we can say that it is a DFA. Why? Because from Q1 A and B goes, from Q2 A and B gives to the another state. It is the deterministic finite automata for that particular language. So in the next video we will see some more examples for construction of DFA. Thank you students.